Pre-distribution scheme in wireless sensor network on Project Virtual Expo. A wireless sensor network is a network of spatial distributed sensor nodes which collect information from the surrounding environment and send the information to the base station for the end user for analyzing the data. So this design is called as a balanced incomplete block design and is denoted as VDRK lambda, and this is used for deriving the secret keys to the sensor nodes.
I'm Sai Lakshmi. We are going to present on our project on machine learning based reward bin for effective waste segregation. We are from BMS IT. As we all know, waste segregation is a process, it's a very tedious process where there are different waste that is being dumped into one spot, and hence because of this there is no easy way of segregation. Hence manual segregation is the only goal that countries with big population deal with, and hence our model is to it aims to reduce this manual segregation and aim on detecting waste and segregating them on machine basis with low human interference. So going on to the objectives, it is our model is to create a model for categorizing and collecting the bottle waste from the waste that is being disposed into the system.
Coming to the block diagram, as it is visible on the screen, you see that Raspberry Pi is the main model, and it is being connected with the IR sensor, servo motors and ultrasonic sensors. And the main objective is the reward system, where for every disposal of the waste, the user is getting a reward.
This is the model, this is the platform, and we have a sweep system. This is a Pi camera, a Raspberry, and our 3 compartments and a reward.
Analysis and performance of machine learning algorithm on disease diagnosis.
Machine learning, it is subdomain of artificial intelligence that provides system the ability to automatically learn and improve from the experiences without being explicitly programmed. That we probably use them dozens of times a day without even noticing it. Since its primary job is to analyze and predict the output from the data, it is also called as predictive analysis. Machine learning algorithms are a part of healthcare right now. So we can predict important clinical events, forecasting treatments that a patient might need. Those are like really important for healthcare. The model with the best accuracy is picked and later retrieved through an unpickling process. The user here enters the required details such as gender, age, other clinical symptoms here. It is, in simple words, it is a matrix that compares the actual target values with those predicted by the machine learning model.
Project on face recognition, which is done using MATLAB. You may be wondering why one of the popular figures in Hollywood's face is here. So let me tell you a bit of a backstory. I was watching one of the movie where in one of a scenes, a street camera recognizes his face and pops his name out. So I was like, okay, can we do this on our personal laptop with high accuracy? And from there, that's how our journey started. Our first objective was pretty clear. We had to successfully recognize Jason's face and put his name out. So if we are able to successfully do it on a personal computer using the image with high accuracy,
Google image search and have large variation in pose, age and illumination. Using the modulus trained on this dataset, they got the output. Face recognition using PCA and FPGA based embedded platform. Here they have used LDL, linear discriminant analysis. It is used in statistics to find a linear combination of features that separates two or more classes of objects.
This is the problem definition we have chosen, that is to develop an efficient system of segregation of dry, wet and metallic waste, and that is a basic level, and it should be least cost and most appropriate technology. When we talk about the rapid waste, because as the population increased, there used to be a voluminous increase in the generation of waste, and talking about the survey data, we got to know that approximately 170 gram of waste is generated by a small house in a small town, and it may go up to 62 million tons of municipal waste per annum.
We are representing our project on the spectrum allocation techniques in cognitive radio network. We see rapid evolution in technological advancements such as 5G, which brings higher speed and lower latency. However, this can be a considerable advantage when connecting massive numbers of sensors and smart devices. But the spectrum available, we know it is a scarce resource, and it's very hard to find free spectrum to support upcoming volumes of wireless devices and mobile data traffic.
So here what it does is it waits for the primary user to empty the channel which is available, and then it gets allocated to the secondary user. So here we, for illustration purpose again, we have considered primary user 3 has ended his particular duration for which he needed, and then that particular channel 3 is allocated to the secondary user which has made the call.
A deep learning algorithm to detect gaming disorders using EEG based emotion states. This project is mainly about we know the introduction of the online games, it has been addictive among the youths, and also this is a concern because it's associated with mental disorders when it reaches a certain point, so it concerns the parents and also people surrounding them. So this is the filter implementation, while implementing in the real-time project, we cross-verified for when the EEG signal is acquired from the electrodes. It is first power amplified, and then the notch filters and the bandpass filter is used to filter the signal, and then it's fed to the microcontroller, and the post-processing will be done.
I'm going to be explaining about my project, Airborne Motion Tracking. So the contents of the slides contain introduction, motivation, problem definition, objectives, methodology, testing and results, references. This technology has been used by military as well as civil aviation, and we plan to use continuously FMCW radar.
So that is a subsystem. If you expand that, you can see the image below here. So in this what I've done is there's a mask filter and 2 time varying gain, and other one is non-coherent detection block. Both of them form a subsystem that will be uploaded to a processor. That is, we're using Raspberry Pi. That will be in a loop, and if you on verification, you can see that both are matching.
My name is Akshata SM. So our title is Development of Printed Antenna using coplanar waveguide feed and defective ground structure. It's like slots, DJs and coplanar waveguide feed. After incorporating any of these approaches, so we get our simulators, and if required, we go for fine tuning of the parameters, and after getting our simulation result, so fabrication of the antenna, and after we get the fabricated antenna, so we test this antenna using DNA. Once we get the measured results, so we compare our measured results and simulation results. So there we can see like what frequencies we have got in simulation results. So the same thing we get in our measured results.
So coming to the antenna design, so this is our antenna design which we have designed, that is using the coplanar waveguide. So the dimensions of this antenna is 30 x 30 x 1.6 mm cube, and the other dimensions like measurement of patch, field and the other ground plane measurements have been shown in the table. So we can try for more frequencies, and as you can see, we had got another frequency that is 3.5 gigahertz that is applicable for WiMAX application. So we can go for more frequencies, and we can go for a wideband application also. So.